started. I'm going to pause the ocean sounds for just a second. And let's do this thing. Okay, so name should already be on there. Okay, especially if you're a kid that's going to be turning them in for me to keep. Okay, name goes on there. Unit 10 is all about waves. There's going to be, I guess, like 4 different sections that we're going to talk about. Okay, this first section is just going to be about those transverse and longitudinal waves that we kind of talked about in that introduction paper. First of all, let's go ahead and give a definition for wave. A vibration that carries energy from one place to another. A vibration that carries energy from one place to another. Do me a favor, I want you to put a circle or a star or something around the word energy. Okay, that's the important part here is energy. A vibration that carries energy from one place to another. Okay, and then I want you to draw a picture of what you think a wave looks like. Like mine is ocean waves. Okay, cute little fish. Alright, you're just going to draw a picture right there of what a wave looks like. Nothing special there. You don't have to be artistic or anything. Okay, let's go ahead and talk about the 2 types of waves that we have. Okay, transverse and longitudinal. We've already mentioned these in that introduction activity, but let's go ahead and put them down in our notes. Okay? Don't walk in front of my camera. Every wave that exists is one of the following 2 types. We have transverse waves. We're going to write a definition or fill in those blanks. A wave that vibrates at right angles to the direction that it travels. Okay? This unit, you get to use your notes on your test. But if you don't take notes, then you don't have anything to use. So it's kind of on you. Sound good? So transverse waves are going to be more like up and down, like you would typically draw a wave. The direction of the vibration is up and down, and we're traveling at a right angle. Okay? I remember that because the T in transverse forms a right angle if you draw the letter T. Jay-Z, I need you not to interrupt me, please. Okay, so transverse is going to travel at right angles. Longitudinal, in our introductory thing, it talked about a slinky. Okay, it looks the same. All right, it's not going to have an up and down that we see in transverse waves. It vibrates in the same direction that it travels. Vibrates in the same direction that it travels. All right, what we're going to do next is underneath these 2 boxes, we're going to write common examples of both of these. So our examples that we like to use for transverse waves are light waves and ocean waves, okay, or any waves that deal with water. Okay, so that's our 2 examples for transverse, light waves and ocean waves. And for longitudinal, it's going to be sound waves and seismic waves. Does anybody know what seismic waves are?
Nope.
What is that? That S word is kind of used with certain phenomenon that happens on Earth sometimes. The ground shakes. Earthquakes, yes. Okay? Seismic waves cause earthquakes. And those are longitudinal waves. Is everybody good here? Alright, so that's our 2 types. Next we're going to start talking about parts of a wave. You will have to label these things on your assignment tomorrow. Okay? These 3 that we're labeling today is pretty simple in my opinion. It makes a lot of sense. Let's go ahead and write down some definitions here. So we have our rest position, which is this black line running through the center. Okay? If we go back to our 2 types of waves, what type of wave is this? That's a transverse wave, okay? Because it has the ups and downs. All right, rest position, that line that goes through the middle, that's the exact definition. Line through the center of a wave. That easy. Okay, we have the crest, which there's going to be multiple in a wave. Okay, the crest is the highest part of the wave. High parts of a wave, peaks if you want to call it that, but I will be using the word crest. The opposite of a crest, the lowest part of a wave, is called a trough. Low parts of a wave, valleys if you will. There's multiple of those as well. Think we can handle that? Think you'll be able to label that tomorrow? Okay, we'll add more labels as we go, but that's it for right now. All right, now we have properties of a wave. There's going to be 3 of these that we talk about today: velocity, wavelength, and frequency. Let's go ahead and knock out velocity. We use the following terms to describe a wave's size, shape, and motion. Velocity, how fast a wave travels from place to place. How fast a wave travels from place to place. And we have a unit there. I need you to fill in m/s. That's our unit for velocity. It's the same as whenever we were calculating speed or calculating velocity like 2 units ago. Okay? Units never change. Alright, so that's just going to be how fast this wave is moving. Okay? Wavelength, how far between crests or troughs of a wave. So distance. Okay? What's a common unit that we've used for distance in the past? Like, think about a distance, meters, and that's exactly right. Our distance for wavelength is going to be meters. Okay, so this is between 2 crests that are beside each other. Okay, so it's not going to be from this crest to this crest. It has to be 2 that are beside each other. You can also measure it with the troughs as well. So this could also be a wavelength. Does that make sense? So between 2 crests or between 2 troughs is our wavelength. The more spread out they are, the longer it's going to be, all of that, okay? Measured in meters. All right, the third thing that we're going to talk about today is frequency. If you were to describe somebody, like, what does frequency mean? Like, if you, like, I'm a frequent visitor to Mojo's, what does that mean? I'm up there a lot. Okay, I have a high frequency when it comes to Mojo's. I have a low frequency when it goes to, like, the gym. I don't go to the gym. I do not frequent it often. Okay, that's the same thing for a wave. The more waves you have, the more frequent it is. The fewer waves you have, the less frequent it is, if that makes sense. Let's go ahead and write down that definition. How often waves pass by a certain location? I pass by Mojo's often. I do not pass by the gym often.
You don't pass by it. You go to it.
Yeah.
Yeah, you pass by.
I enter the facility.
So you pass by the gym.
You,
Kittens. Yeah, look.
I am on video.
Oh.
Okay? Our unit for frequency is something that we call hertz, and it's going to be labeled with a capital H and a lowercase z. Make sure that that H is capitalized. Okay? Capital H, lowercase z. Okay, now with these 3 things that we just talked about, velocity, wavelength, and frequency, there's going to be a formula that we're going to use that relates all of them. Okay? These properties of waves are all related by the formula. Velocity equals wavelength times frequency. Okay? We are going to have a handy dandy triangle for this. Whoa. I can erase these guys. All right, everybody do me a favor. Somewhere on your paper, wherever you have room, I want you to draw this triangle. Okay? We've used this triangle several times before with different stuff. We get to use it again. All right, V is going to go on top for velocity. And then we're going to have wavelength, which is represented by a lambda sign, which is like an upside down fancy Y.
Kappa Lambda.
So, boom. Okay, it's weird. Just an upside down Y pretty much. That is going to be wavelength. And then an F is going to be for frequency. Alright, so let's work these 3 examples and then we are going to be done for the day. What is the frequency of a wave that travels at 4.5 meters per second and has a wavelength of 2 meters? Okay, so I have velocity that I'm working with, I have wavelength, and I have frequency. What is my velocity in this problem? 4.5, because meters per second tells me velocity. Okay, so B equals 4.5. Wavelength is 2 meters. So I am looking for frequency. Somebody tell me what I'm going to do with my math. Divide. Okay, I cover up my F because I'm missing frequency. V over wavelength. Velocity over wavelength. So 4.5 divided by 2. 2.25. And what unit goes with frequency?
Hertz.
Hertz, which is capital H, little z. Okay, so this one we found frequency. Middle one, how fast does a wave move if it has a 9-meter wavelength and a frequency of 3.5 hertz?
Wait.
Missed. Velocity, wavelength, frequency. 9 meters is what? Wavelength. 3.5 hertz is frequency. How do I find velocity? I'm going to multiply. Okay? So 9 times 3.5 is going to give me 31.5 what for velocity?
In there.
Yep. 31.5 meters per second. Okay, y'all are going to get 1 minute to do this problem. Try to do this on your own. I will give you my answer in just a second. So we have 8 meters per second and we have 10 hertz. Brooke, what'd you get? What did I get? The same as you. Good job. Alright, somebody really quick, tell me what math did you do? What number goes on top? 8. Okay, make sure we always have velocity on top. So meters per second gives me velocity. Hz is frequency. I divide those. And what'd you get?
9.
Yep. What's my unit? Meters, because I'm looking for wavelength. Okay, do we have any questions? Do you think you can do a couple math problems on your own tomorrow? Cool beans. That's it.